Consider INPEX, one of Japan's largest energy development companies. As the world pursues an energy transition to net zero, we strive to provide a stable supply of lower carbon energy and realize a responsible energy transition that is sustainable and environmentally friendly. At INPEX's core business areas in Japan, Australia, Abu Dhabi, Southeast Asia, and Europe, our top priority is the safe and stable operation of oil and natural gas development projects. By 2035, we aim to expand our natural gas and LNG business, provide lower carbon solutions leveraging CCS and hydrogen, and drive initiatives in the energy and resources fields by leveraging INPEX's distinctive capabilities. We will tackle global challenges through energy by focusing on these three pillars of growth. At the INPEX Japan Nagaoka field office, where you are now, we are engaged in the development of oil and natural gas, which consists of exploration, drilling, evaluation, development, production, and transportation. As one of the largest natural gas production sites in Japan, this facility encompasses the entire supply chain. The history of natural gas in this area dates back to a time when the Japanese archipelago was still submerged under the sea. As undersea volcanoes erupted, their lava cooled and hardened in the seawater to form volcanic rock. This is the main natural gas reservoir of the Nagaoka gas field. There are numerous formations underground, but this particular natural gas reservoir lies between 4,000 and 5,000 meters below the surface. It is called green tuff because its rocks are greenish in color. Green tuff is covered by cap rock, a solid layer of rock that does not allow gas to pass through. This dense cap rock has prevented natural gas from reaching the surface, causing it to accumulate beneath the rock and form a natural gas reservoir in Nagaoka. In addition to the well sites that produce gas, the Nagaoka gas field at the Nagaoka field office mainly consists of the Kochijihara plant and Oyazawa plant for gas refining, and the Sekihara plant where gas is injected and extracted, serving as underground storage for a portion of the natural gas produced from the Nagaoka gas field. Let's take a look at the role of each facility. First are the production wells in the well sites. These facilities use pressure to facilitate the flow of light oil and natural gas from 4,000 to 5,000 meters underground. For safety, several valves are also installed to stop gas production in an emergency. Gas produced in the wells enters the plants through flow lines. At the Koshijihara and Oyazawa plants, impurities are removed from the natural gas transported by the flow lines. After adjusting the heat content of the gas is sent to pipelines as refined gas. Condensate, a light liquid hydrocarbon that is separated from natural gas in the plants, is transported by trucks to the oil terminal in Naoetsu. It is utilized as a raw material for petroleum products such as gasoline, naphtha, and diesel fuel. The Sekihara plant also functions as Japan's first underground natural gas storage facility. The plant is currently operated in coordination with the volume of liquefied natural gas, LNG, received at the Naoetsu LNG terminal. When demand exceeds supply, gas stored at the Sekihara plant is extracted. On the other hand, when excess gas is generated, it is injected into the reservoir. In this manner, we are building infrastructure for the stable supply of natural gas by conducting injection and extraction operations as needed. Natural gas refined at the Nagaoka gas field is sent to city gas companies and manufacturing plants in various regions. The total length of our pipeline network is approximately 1,500 kilometers. Today, in order to reduce CO₂ emissions, one of the causes of global warming, the world needs low-carbon energy sources that minimize environmental footprint. At INPEX, we strive to provide a stable supply of oil and natural gas, both of which are indispensable to our daily lives, while also supplying lower carbon energy. Our aim is to achieve a responsible energy transition. First, let's look at our lower carbon solutions leveraging CCS and hydrogen. CCS is a technology that captures CO₂ emissions from fossil fuels and other sources and stores that CO₂ underground. One solution being promoted is the Metropolitan Area CCS project. CO₂ is separated and captured from exhaust gases in the Keio industrial zone and transported via pipelines to be stored deep underground off the Kujukuri coast, with the aim of contributing to carbon neutrality. Hydrogen and ammonia are also being touted as promising clean energy sources that do not emit CO₂ when combusted. In the city of Kashiwazaki in Niigata Prefecture, we have built Kashiwazaki Hydrogen Park, a demonstration facility for the production and utilization of blue hydrogen and blue ammonia. Here, we are working to make these low-carbon energy sources fit for practical use. First, natural gas, the raw material for hydrogen production, is transported from INPEX's Minami Nagaoka gas field via existing pipelines. Then, CO₂ generated during the production of hydrogen is injected into a depleted gas field in the Hirai district of the Higashi Kashiwazaki gas field. In this way, we aim to produce blue hydrogen, or hydrogen that is manufactured without emitting CO₂. Here in Nagaoka City, Niigata Prefecture, we have also built a facility to demonstrate the implementation of methanation technology in society. This technology uses hydrogen and carbon dioxide as raw materials to synthesize methane, the main component of city gas. Compared to other energy sources, such as coal and oil, natural gas produced at the Nagaoka field office is a source of clean energy with low CO₂ emissions. However, natural gas from underground gas fields still contains CO₂ and other impurities. Therefore, CO₂ is emitted when natural gas is refined into city gas, combusted for power generation or used in households. This is why there is growing interest in a technology that reuses the CO₂ emitted during the production and use of energy, such as natural gas, to create methane, the main component of city gas. This process is called methanation. The methane synthesized by methanation is supplied to customers through gas pipelines. More specifically, synthetic methane produced from clean energy, such as green hydrogen, which is created with renewable energy, is called e-methane. Methanation technology has two main advantages. Firstly, it does not increase the amount of CO₂ in the atmosphere. Burning methane produces CO₂ and water, but the amount produced is equal to the amount used in methanation synthesis. The CO₂ is simply circulated and no additional emissions are produced. And secondly, it can utilize existing infrastructure. Because synthetic methane is a main component of natural gas and city gas, existing gas infrastructure can be utilized as is, reducing facility and equipment costs to achieve a low-carbon society. Here at the Nagaoka field office, CO₂ is being converted into city gas through a cutting-edge technology development project called the Nagaoka Methanation Demonstration Project. Here, 400 normal cubic meters of synthetic methane are being produced per hour. This facility that synthesizes methane from CO₂ is one of the largest demonstration projects of its kind in the world. CO₂, one feedstock for synthetic methane, is sent here from CO₂ separation and recovery facilities at the Koshijihara plant of the Nagaoka field office through underground connecting pipelines at a rate of 400 cubic meters per hour. Hydrogen, the other feedstock, is brought in from outside by trucks and stored in tanks while maintained in a liquid state at a temperature of -253 degrees Celsius. From here, the 1,600 cubic meters of hydrogen gas per hour required for the methanation reaction are sent to the methanation area. The feedstocks, CO₂ and hydrogen, are mixed in this methanation area. 3 interconnected methanators synthesize methane, the main component of natural gas. The 3 methanators are controlled from a central control room and undergo demonstration testing under various operating conditions. The synthesized methane is sent through connecting pipelines to the Koshijihara plant, from which it can ultimately be delivered to customers. Because the methanation technology being demonstrated in Nagaoka contributes to the carbon neutralization of natural gas and city gas, it plays a key role in INPEX's responsible energy transition. In order to achieve a net-zero society by 2050, we aim to scale up this methanation technology for domestic and international use, with the goal of spreading the use of synthetic methane, e-methane, in society as early as possible. The Nagaoka Field Office is an unparalleled energy hub like no other in Japan. From this site in Nagaoka, home to one of the world's largest methanation facilities, we will strive to provide a stable energy supply and help achieve a net-zero carbon society.
Energy for a brighter future, INPEX.